Hi everyone, today I'm going to go over Chapter 1, Section 1 of Geometry. So this first section has a lot of symbols and definitions that we'll be using throughout geometry. So the first one is a point. So it'll be represented by a dot and a capital letter. And when you name it, you'll just call it by the capital letter. So for this example here, we have the letter P next to it, so this is called point P. For a line, you'll draw a line with two arrows on the end because the line will go on forever. You'll need 2 points to name the line. So in this case, we have point A and point B, so we can call this line AB or line BA, so you can go either way. And if there's a lowercase letter, you can also call it that. So in this case, we have a lowercase l, so we can call this line L. Next, we have a segment. So it's similar to a line, but instead of going on forever, it actually ends. So it has two specific endpoints. And we'll name this by the two capital letters that make up the endpoints. So in this case, this would be called CD or DC. And when writing the symbols, you will draw like a small little segment on top. So for a line, we draw a small little line on top, which is this part here. And then for a line segment, we're going to draw a small line segment on the top. So next we have rays. So this is similar to a line, but it actually ends on one side. So on one side we have an endpoint and it goes through another point forever. The endpoint is always the letter that comes first when we're naming it, and you'll have a small little ray on the top. So if you look at the top, there's a small ray, and E is the endpoint, which is here, so that's why E is named first. Next we have an angle. So an angle is made up of two rays that connect at the endpoints. So for this example, we have ray GJ and ray GH. So that means they both share the endpoint G. So there are three different ways to name this angle. You can name it by the vertex, which is this point here, which is the endpoint that they both share. So in this case, this can be called angle G. Or you can call it by the number on the inside. There won't always be a number on the inside, but if they do, you can call it by that number. And you can also call it using all three letters. And you have to make sure that the vertex is in the middle. So you can call it H, G, J, or you can call it J, G, H. And for the symbol, you'll have a small little angle sign in front. Now for plane, this is a slanted four-sided figure. You can name it by any 3 points on the plane. They don't have to be on the edge, it could just be anywhere on the plane. And sometimes they'll include a capital letter on the corner, and that's how you can name it as well. So one of the facts about this is that it goes on forever in all directions, so it doesn't end. One of the names could be plane KLM, or you can also call it plane N. So if there's no dot next to it, that means it's not a point, so that means the name of this is N. Next, we're going to talk about collinear. So collinear means points on the same line. So in the example here, we have points H, E, and Y all on one line. So all of those are collinear. And you can pick any 2 points on that line to name the line. So we can call it line HE, EY, HY, etc. Now for the next example, we have two lines intersecting and it kind of looks like an X. On one line we have the points G, A, and P, and on another line we have the points C, A, and B. We're looking for collinear points. So G, A, and P are all on the same line, so those are collinear. C, A, and B are also all on the same line, so those are collinear. Now coplanar means points lying on the same plane and any 3 points that are not collinear. For this example here, we have a plane with point Q, R, S, and T all on the same plane, so those are all coplanar. And point V doesn't look like it's on the plane that's drawn, but it's also coplanar with any 2 points on the plane, because we can make a plane that goes through point V and any other 2 points on the plane given. Opposite rays are two rays that start at a common point and go off in opposite directions, and they're going to make a 180-degree angle. So in this example here, the common point is y, and we have the ray yz going in one direction, and we have the ray yx going in the other direction. So that means ray yz and ray yx are opposite. So here we have an example. The first question asks, give two other names for line AB. So line AB is right here, and if you remember, one of the ways to name the line is by calling it the lowercase letters, so we can call this line H. And another way is to flip the order of the capital letters. So we can also call this line BA. Okay, the next question is name three collinear points. So we're looking for 3 points that are all on the same line. If we look at line AB that we were looking at earlier, there's no other points, so we can't use that line. The other line that we have is here, line G. And on this line we have the points C, B, and D. So C, B, and D. And all of those are on the same line, so that's why they're called collinear. Give another name for plane F. So F is right here, so we're looking for the name of that plane there. And for this, we'll need 3 points. So we can call this plane A, B, and E, since these 3 points here are on the plane. And it doesn't matter what order you put these letters in, you can also call this AEB, BAE, and any other variation. Number 4, give another name for CD. So line segment CD is this part here. And since it's a line segment, the only other way to name it would be to flipping the order of the letters. So it would be line segment DC. Next we have name three rays with endpoint B. So endpoint B is right here. If we try to go this way, there's no other letter there, so we can't use that as a ray. But if we go down, we have the ray BD. If we go to the right, we have ray BA. And if we go up, we have the ray BC. And don't forget, for rays, the endpoint is the letter that comes first when you're naming them. Okay, next we have name a pair of opposite rays. So to do this, I usually look for the lines, and then I see if they have at least 3 points, because we need at least 3 points to have opposite rays. So for line AB, there's only 2 points, so there are no opposite rays. But if we look at line G here, there are two opposite rays, which are BD and BC. Okay, the next problem says give another name for line CD. So that was this line here. So we can call this line G. We can call it line DC, so we can flip the order. And you can use any 2 points to name this line. So we can also call it line CB and line BC, or line DB and line BD. Okay, this next section is about intersections. Name the intersection of line KL and PQ. So when two lines intersect, they're going to intersect at a point. So for this problem, we're looking for where KL, which is right here, is going to intersect with PQ. So if you look, the common point is J. So they would intersect at point J. Okay, in the next example, we have name the intersection of line PQ, which is here, and plane KMN, which is this here. So if you look at line PQ, it has a dotted line from J to P. That just means that the line PQ goes through the plane. So like JP is under the plane, if that kind of makes sense. So if you can imagine like poking a hole with a pencil through a piece of paper, where they intersect is going to be a point. So the intersection is going to be point J, since that's where your pencil will go through the paper. Next we have name the intersection of plane R and plane S. So when two planes intersect, if you think about two pieces of paper crossing each other, they're going to make a line at where they intersect. So for this, it would be line MN or line MJ or JN or any variation. So I'm not going to list them all, but you can switch the letters and those will also be correct. Okay, next we have determine if a point is on a line. So in order to do that, you're going to plug in the point x, y into the equation to check if it's true. So for our first example, we have is point A 517 on y equals 4x minus 3. So that means we're going to plug in 5 for x and 17 for y. So we get 17 equals 4 times 5 minus 3. So 17 equals 20 minus 3. And that's a true statement, so the answer would be yes. Next we have is point A, negative 1, negative 3 on 2y equals negative 3x minus 9. So that means we're going to plug in negative 1 for x and negative 3 for y. So we'll have 2 times negative 3 equals negative 3 times negative 1 minus 9. 2 times negative 3 is negative 6. Negative 3 times 1 is 3. So we have negative 6 equals 3 minus 9, which is true, so this is yes. Next we have is point A, which is 6, 4 on 6y minus 7x equals 8. So again, we're going to plug 6 in for x, 4 for y. So we have 6 times 4 minus 7 times 6 equals 8. So that's 24 minus 42 equals 8, which is not true, so the answer would be no. Okay, the last section, graph the inequality and determine if the graph is a segment, ray, raised point, or a line. So for the first example, we have x is greater than or equal to 6. So the numbers that would make this true is any number that's bigger than 6. So that means at 6 we're going to have a point, and we're going to shade to the right. So if you draw this out, it'll look like a ray. Next we have negative 4 is less than or equal to x is less than or equal to 2. So that means x can be any number between negative 4 and positive 2. So when we draw that, that's going to be a line segment. Next we have x is greater than or equal to 4 and x is less than or equal to 7. So since the problem says and, that means we want the section where it's true for both. So 8 is greater than 4, but it's not less than 7, so 8 wouldn't work. And 3 is less than 7, but it's not greater than 4, so that doesn't work. So that means for this graph, we only want the section between 4 and 7, so this is going to make a line segment. Next we have x is greater than or equal to 0 or x is less than or equal to negative 2. So for the first inequality, we want the point to the right of 0 because that's where it's greater than 0. And then for the second one, it says x is less than or equal to negative 2. So we want the points that are to the left of negative 2 since it's less than. So here we have 2 rays. For the last two examples, we have x is less than or equal to 2 or x is greater than or equal to negative 1. So if x is less than or equal to 2, we'll have a point at 2 and we'll be shading to the left since that's where it's less than. And then for x is greater than or equal to -1, we'll have a point at -1 and we'll be shading to the right since that's where it's greater than. So since it's the OR problem, it just has to satisfy one of the two equations. So 3 is greater than -1, so that would work for our problem. And -2 is less than 2, so that would work for our problem. So that means this is going to make a line. Okay, and the last example, we have x squared is less than or equal to 0. So the only number that we can plug in is 0. So this would make a point. Okay, thank you so much for watching. I know this video was kind of long, but leave a comment down below if you have any questions or reach out to me, and I will see you next time with my next video. Bye!